This lecture is for the living Earth as we continue Unit 1.1. We're still talking about Earth's spheres. Likewise, we are continuing to build our response to the essential question, what are the major components of the Earth system? In previous lectures, we have dealt with the geosphere and the hydrosphere. In today's lecture, we are going to deal with the atmosphere. The atmosphere. The atmosphere consists of a gaseous mixture of air that surrounds the surface of the planet. Volcanoes released many of these gases, and they currently make up the atmosphere. Nitrogen specifically dominates the mixture because it does not react with minerals and rocks on Earth's surface. So it stays there and continues to build. The concentration of nitrogen has therefore increased slowly throughout time. At the current moment, it makes up about 78% of all gases in the atmosphere. The next most abundant gas in the atmosphere is oxygen, which is stabilized at about 21%. The oxygen that you breathe in the atmosphere is a product of tiny photosynthetic organisms mostly. The remaining gases, right, not nitrogen, not oxygen, but the remaining gases occur in our atmosphere in trace amounts, which means very, very small amounts. Before I go any further, please note that this pie chart of trace gases only represents the 1% left over of atmospheric gases that is not nitrogen and not oxygen. So several of these trace gases have a tremendous impact on our planet. Carbon dioxide, water vapor, methane, sulfur dioxide, ozone, and different nitrogen oxides are all greenhouse gases. Greenhouse gases absorb long wavelength radiation from Earth's surface that is heated by the sun. The higher the concentration of greenhouse gases in the atmosphere, the more heat is kept close to the planet's surface. If the atmosphere did not absorb this long wavelength radiation, the planet would still heat up during the day. However, the heat would then be lost into the upper atmosphere at night. And this potential rapid transition in temperature during this 24-hour cycle would affect the ability of life to survive on the planet's surface. Let's look at some specific concentrations of atmospheric gases. Atmospheric gases. So you can see the table on the screen lists the concentrations of gases that make up Earth's atmosphere. And yes, you will want these numbers in your notes. The most common gas we have in our atmosphere is nitrogen, represented as N2, coming in at 78.08%. The second most common gas being oxygen, O2, coming in at just under 21%. Again, you will want these concentrations in your notes, so please include these as well as the representations. It is very, very convenient to know that, for example, ozone is O3. It's much easier to write that symbol O3 than it is to write out the word ozone. That'll do it for today's lecture, in which we explored Earth's atmosphere as we continue to build our response to the essential question, what are the major components of the Earth system? We have now covered the geosphere, the hydrosphere, as well as the atmosphere.